Okay, hello everyone. This is the additional video for chapter 15, at least 15.1.2.3 and also point 5, the surface area. So let's start with these questions. Okay, you can stop the video and try to look at the question, and probably you can also try to figure out. Okay, I think we can just going through the questions. So we have the x squared plus y squared equal 1 and x squared plus y squared equal 9 for the region. So this is x squared plus y squared equal 9, and this will x squared y squared equal 1. So we could start with writing down the conversion. If you forget, this is the conversions. Okay, from the Cartesians to polar. So every time you see any curve that can be easily converted to polar, which is sometimes it's really obvious that it's a circle or circular or any that you can easily convert to polar. So we can convert this and write down the write down the integrations. So right. Okay, now in the angle, the theta is from 0 to pi, right? So we could start with 0 pi, and then the radius is 3 and 1, so it starts from 1 to 3, and the inside will be 3 3r cos theta, correct, and then plus 4r squared sine squared theta, and then this will be r dr d theta. Okay, now let's start with the inside integrations. So we could write this becomes 3r cubed uh, 3r squared cos theta plus 4r cubed sine squared theta. Okay, we can integrate with respect to r, so this will be r cubed cos theta, and this will be r 4 sine squared theta from 1 to 3. Still we have integrations from 0 to pi, and then the d theta. Okay, now next we put in the numbers. 27 minus 1 is 20. Okay, sorry for the my Apple Pencil battery seems 0, so okay, let's continue. Okay, so this will be 26 cos theta, and plus this is 81 minus 1 should be 80 sine squared theta, and then this d theta. Okay, we should get 26 sine theta, and then we get this is we're going to change to 1 minus cos 2 theta over 2. Okay, so we have plus 40 1 minus cos 2 theta d theta, and this is 0 to pi. This will be 0, and this will be goes to, this will be sine, and sine will be 0, so 40 pi is our answer. Okay, that's the D. Okay, I hope you get the same answer with me, but let's get going to the next questions. So we have another one is this is iterated integral, just as usual iterated integral, and you could pause the video and we could work out the answer together. Okay, now if let me just write the questions again here. 0, 1, or let me write this in terms of 1 over 1 plus x squared dx dy. Okay, now how do we solve this? Can we solve this through some techniques? Okay, I think if you look at the end points, we could see that this will be the interval, right? So if we could write down as a sketch, we could have, this is 1, this is 1, okay. Let's say this is y equal x. So we could have the y from here, okay. And then for x, it starts from y to 1. So here. So this is our area, right? So what could be done if we try to reverse the order? If you would like to dy dx, then we could start with the x is 0 to 1, right? So x is 0 to 1. This is the one we would have. And then the y will be from 0 to the x, right? So we could write the new integrations. Okay. Now, we could integrate this, I think, easier than the previous one. I think if you want to force integrate this, probably you could get, not sure what is the integral of this one, right? Or you could see that this will be related to the tangent inverse, probably. Okay, but let's just take this into the solution for this one. Okay, let's say we could have this. So we could have we could have some substitutions, and then we could have, this is half, and then ln 1 plus x squared from 0 to 1, and this could be half ln 2. Okay, and then this will be our answer. So this will be our answer, D. Okay. You get same results with me? Okay. Now let's go for the next questions that I have prepared for you. Okay, next questions is, we have this double integral, and it seems we have the square root. Okay, so before I'm going through the solutions, perhaps we could take a look at the questions. So we need to have the double integral, okay, and the most obvious points here is this and this. Okay, now whenever you see these reasons or this particular square root or any x squared and y squared for in a equations in a double integrations, probably that is uh, one signals that probably you need to convert to polar. Okay, you can stop the video and try to find the solutions, but let me just get through the solutions. Okay, let me write the double integral. So we could write this x is from 0 to 1 and y is from 0 to square root of 1 minus x squared. Okay, now what could happen? So we could say that we could have this circle. So we could draw first to sketch roughly what is our region. Okay, let's say this is a circle or circle, and then we could say that it starts from 0 to 1. Let's say 1 is here. Okay, now since the x is start from 0 to 1 from here, and y is from 0 to this, so we could have that area. Okay, so we could write the polar. This is the angle is from 0 to pi over 2. The radius is 0 from 0 to 1, and then this will become e with power of negative r squared r dr d theta. Okay, and then we could say this is pi over 2 and re, this re we could write down using the, if you want to use partials, I think we could do that. So you could say that we have the I method. So let's say r, and then this is e, and this is not minus, sorry, it should be 1, and this will be e minus r squared, and minus over 2, right? Over 2 let's say we could check if we want. I think we still need to write down the r, right? Oh, I think we could just directly say, because if we derive this, so I think we could get directly the answer, right? So we could say that this will be related to minus, right? Because we have minus, so we do have minus e r squared and then over 2. Okay, if we take derivative, we could get, let me just write here, minus 2 re minus 2r r squared where did I need, oh sorry, should be e r squared. So minus 2r, so plus r to r, e minus r squared, and then 2. So yeah, it's going to be our answer. So we could get directly, so pi over 2 e negative e and then negative r, or we could write, maybe just write this first. Sorry. So this will be, we put 1 inside and we put 0. So because of the negative, this will be 1 minus 1 over e, right? E minus 1. Okay. And this will be our answer, right? Or did I make something wrong here? Let me check. Oh, it should be pi over 4, sorry. So it should be A. Okay. 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 Now let's go to next questions, which is I prepare for the surface area. Okay, let's see our questions here. Surface area over the disk, we have the disk x squared plus y squared less or equal to, and we have a circular parabola z equal x squared plus y squared. Okay, now we could write down z as our function of xy. That is the function that we need to observe. So partial x we could have 2x, partial y we could have 2y. Okay, if you remember how to develop the surface area, and r is the x squared plus y squared, and then the equal to, right? Okay, let's say we are going to have because we have 2x and 2y, we could write, let's say we could write dA first, right? And then let's input the variable x and y inside. So we could have 4x squared and 4y squared. So let me write x squared plus y squared plus 1. Okay, let's say we have r like that. And I believe this x squared plus y squared is our reasons. Okay, this will be the reasons for conversion to polar. So let's do the conversions to polar. So we could have, this is a circle with radius 2, right? So we could have 0, 2 pi, and 0 and square root of 2. And we could write this in 4r squared plus 1. And then let's say this is with power of half. And then r dr d theta. Okay, we could start with, this is 2 pi. And 4r squared plus 1, this could be using these substitutions, it's 8r dr equal du. So du is 1 over 8r dr. Or let me just change this rdr. So rdr is 1 over 8 du. So we could change this. So we could write down squared u. This is 1 over 8 du. So this could be 3 over 2, 2 over 3, so 1 over 12. So 1 over 12, 1 over 12, so 1 over 12, square root of 2, this will be 8, and then 1, 9, 3 with 3 is 27, so 27, and then minus 1, right, so 26. So 26 over 12 seems, and then 2 pi. So 6 divided by 2 is 13 over 3. So 13 over 3 pi. I hope you could understand my writing here. So this should be 13 over 3 pi. Okay, that's, I think, the end of this additional video. I hope you can learn from this additional video, and okay, see you in the class. Okay.